Hello, good evening everyone. Good evening everyone. I welcome all of you to Gradeup channel. Welcome all of you to Gradeup channel of YouTube. I hope all of you are doing good and staying safe. Come on, join me as early as possible and let us start our session for the deflection. Fantastic questions on deflection will be discussed now. Am I audible to all of you? Am I audible to all of you? Hello Kavya, good evening. A very good evening to all of you. Am I audible to all of you? So you are studying with me on champion study plan, that is Gradeup champion study plan, one of the fantastic plan for gate 2022, isn't it? Please share it once and we'll start within a few minutes. Within a minute we'll start. So I hope all of you have already completed few of the subjects. Those who have not completed, please go to the description box, and in the description box you'll find the schedule. Just try to click there and you'll find a very nice schedule provided there. Okay, so here I am. Hello Samrita. Good evening. Good evening. How you all are doing? Studying well? Practice as much as question you can, right? But first of all, you try to cover up your syllabus. That is also very necessary. Cover your syllabus. So if you are really preparing for GATE 2022, solve previous year question, cover your syllabus appropriately, whatever the time available you have now. From here, plan it and go with the planning, right? Now this Gradeup civil, that Gradeup provides civil champion study plan, one of the fantastic plans. Hmm? Now today we will discuss about deflection of beam. Here I have a small introduction about me and 9+ years of experience. There's a vision batch for 2022 in English and Hindi as well. For vision 2023 also for GATE and ES. You can subscribe there. These are the star faculty of the Gradeup. The one which I was discussing about champion study plan, a 120 days free course of GATE for 2022. There is a test, that is mega mock challenge for BARC 2021 on 29th of August. Now here is the first question for you. Moments of the same sense are applied to both the ends of a simply supported beam. The ratio of the rotation of two ends is 2. What is the ratio of the applied moment? Can you do this one? What will be the ratio of the applied moment? Hello Samrat. Samrat. After so many days, Samrat. Hello Mustaqim. Good evening everyone. What will be the answer for this one? How you will solve this? What will be the answer for this one? What will do? Which one is correct? Can you do this? Here, moments of same sense are applied to both of the ends, right? If moments are applied, okay, I think red is okay. Okay. To a simply supported beam, if moment of same sense is applied, suppose if I'm applying a moment of same sense, means suppose in a clockwise direction both. Suppose this is MA and this is MB, right? Moments of the same sense are applied both. And simply supported. The ratio of the rotation. Now rotation, if you will apply the moment, both the moment will try to. Now imagine if you are applying MA, what kind of rotation you will be having here. MA will produce what? MA ml by 3I here, and this will produce ml by 6EI here, isn't it? This MB will produce MB. I'll change the color. MB will produce MB, that is ml by 3I here, and it will produce the rotation, that is ml by 6EI here. Did you get that? But the problem is that here the rotation, the nature of the rotation, you need to understand. MA will produce here a clockwise, and MB will produce, I'll just mark the deflected shape of the beam. MB will produce this type of deflected shape. So the nature of rotation will be opposite, isn't it? Nature of rotation, here it is rotating in other direction. So what I can write down, MA L by 3EI minus MBL by 6EI, and here this is producing in this side and this one is producing in other side. So now MAL by 6EI just maybe plus, and this is plus, this is minus. That's all. Now he's asking what is the correct now. This is I'm just considering as clockwise, and maybe this one is clockwise, this one okay. So the ratio of the rotation of the two ends is 2. What is the meaning? The ratio of the rotation, that is ratio of the rotation. Now I don't have any idea about what is the value of MA and MB we are applying there, right? We are just have an idea about what is the ratio of the rotation, that is theta at A. Now the complete theta at A is nothing but MAL by 3EI minus MBL by 6EI, right? That is the theta at A divided by theta at B, MBL by 3EI minus MBL by, correct one, no? 6EI. That is the ratio of the rotation. He is saying that ratio of the rotation is nothing but 2. Now can you solve this? Simplify this one. And what is the ratio of the applied moment? That is what you have to get. L by 3I, L by EI will get cancelled, and in fact you can take 1 by 6 also common. So twice of MA minus MB you will get here, and MB twice of MB minus M. Am I doing some mistake? MA MB here it is MA. I'm sorry, this is MA. Am I correct? No, this is MB. Oh, if I do a little bit mistake, then, and this is MA, right? Small mistakes will create trouble for me also. Now if you will multiply with you take common 1 by 6, it will become how much? Twice of MB minus MA, right? Okay, that's correct. Now equals to 2. Then twice of MA minus MB will be equal to 4 times of MB minus twice of MA. Then what? This twice of MA you bring it here. There are 4 MA equals to how much? 5 MB. Now MB by MA is 5 by 4. That's all. MB by MA is 5 by 4. Did you get that? Oh sorry, MA by MB is 5 by 4. MA by MB is 5 by 4. Are you able to understand this? Oh, you have already solved it, huh? Great. You have a nice speed, Santu. Better than me. Next one. What about this one? An overhanging beam of uniform EI is loaded as shown below. This one I think quite easy, right? The deflection at free end is, what will be the deflection at free end here? Can you do this one? This is very easy, very easy. Several times you would have seen how to approach this, isn't it? Take me red color. Okay, how I'll do this one? The deflection of the free end. What is the approach you are going to apply here? Oh, Samrat is saying semester चल रहा था. Semester exam हो गया. Is it finished, the semester exam? So many places semester examination was going on, right? Now you can do the preparation on a full-fledged, right? And how was that? How's that your examination? Maybe please don't say that, sir. I was too busy in the preparation and my semester exam was not that good. Please. Okay, you have got the answer C. Santu is saying once again it is D. So let me solve this one. It is D. I don't know. I have just not calculated yet. So suppose, see, you have to help me. You need to help me. So see, whenever you are solving it, remember that principle of that superposition will apply. Method of superposition will apply here. One should understand that if this is L and this is L by 2, there are two types of deflection you will be getting here. If you apply the load here, you can understand due to the load and the distance, that is some moment will be introduced here, that is W into L by 2, that is WL by 2. That moment will create the rotation on the beam. Are you getting my point? The moment will create a rotation in the beam just due to the moment which you are going to apply here. Due to that, this portion AB will rotate. Now understand that. And due to the rotation, imagine if there is a no load acting on C. Are you listening me carefully? If no load is acting on C, due to the rotation of the AB, as this is the part of AB, the BC member is a part of AB, it will be rotating like a straight member. If no load is applying there, it will be a pure rotation for the member BC. Are you able to understand that? So whatever the slope you are going to get here, for the rotation, green will be visible, I think. Is it visible? Whatever the theta you are going to get here, same theta you will be observing here. If still I'm not completed yet. If load, I'm assuming there is no load here at the free end. Now what will happen? This straight portion will remain. Now you have a deflection due to the rotation of the member AB due to the applied moment, which is WL by 2. Now can you tell me what is the, for a simply supported one, if you are applying the moment here, what is the slope you are getting it here? Maybe I'm just, what is the slope you are getting it here? At this end you will be having ML by 3I. Agree, no? ML by 3I. So that theta at B, which is ML by 3I, here you have theta at B, and certainly we are going to consider it as R theta. R is what? L by 2. So I can write down theta B into L by 2. That is the amount of deflection due to the rotation of the joint B. Are you able to understand that? Amount of deflection due to the rotation of the joint B. Now imagine once again the load is already acting here. Due to the applied load, now what will happen? The member BC will bend. And you will be getting another deflection due to the bending of the member. Now bending of the member will behave like a cantilever, and due to the cantilever at free end you have a deflection. Now you know that if you have a cantilever and a load is applied at free end, the deflection is PLQ by 3I. That is why all the educators used to say that. Please remember those things, right? Now you have a PLQ by 3I, that is WLQ by 3EI. Now if you have any confusion, please let me know. Now you add these two, that's all what you are looking after now. Those who have not solved it, please add these two. Let me, oh, this much space is there, no? So now if you are adding these two, you'll get the final deflection, that is WLQ by 3EI. And you need to understand that WLQ by 3I, here L is L by 2, so W into L by 2 cube by 3EI and plus theta B, which is nothing but ML by 3EI. So that is ML by 3I. M is already what? M is WL by 2. WL by 2 use M. L, what is L? L is L divided by 3EI into L by 2, Now you tell me how much you are getting it here. Can you tell me? WL cube by 24EI, as in 24EI and plus Here WL cube divided by how much you'll get? 2 4 4 12. Correct, no? Any mistake I'm doing? Now add these two, that's all. 24 यहाँ जोड़ दो, 24 का 24, 12 दूनी 24, 2 1 3, 3 WL cube by 24, so 8 WL cube by 80i. Simple. WL cube by 80i. What about this one? The free end deflection of a cantilever of length L with a couple M acting at its mid. So you have a cantilever and a couple is acting, that is M is acting at mid of the cantilever span. Now what is the deflection at free end deflection? What is the deflection at free end? Can you tell me? What will be the deflection at free end? Very simple. Very simple. Now you already know that for a cantilever at a free end, if moment is applied, what is the theta? What is the theta? That is, if suppose this is A and this is B, it's all depend. If you're applying the method of superposition, want you to remember the theta and deflection for the standard cases, isn't it? Now theta at B, what is the value? That is ml by EI, correct? And what is the delta for that? What is the delta? That is ml square by 2EI. Is it correct? ml square by 2EI. Now use that theta and that delta value to get that. It is very simple. Use that theta and delta value. Can you do this? Now, due to this moment, if this is L by 2, this is L by 2, here your beam is this, and it is going to get deflect till this point. So you will get one deflection due to the moment applied here, which is nothing but one deflection. This one amounts ml square by 2EI. So that is ml by 2 square by 2EI. That is your deflection here, and there is a rotation. Right now this rotation is simply theta, whatever you have here, that theta multiplied by length. So this will be ml by, that is ml by 2 by EI multiplied by r theta, right? Theta have already done. What is r? That is L by 2 once again. Now can you just add these two? How much you'll be getting it here? ml square by 2 4 8 80i, and then plus ml square by 2 4 ml square by 4EI. Am I correct? You take 8 here, I take 3 by 8 ml square by EI. So you have answer C. How many of you have given the correct answer? Ashish, Kavya, and Samrita. All of you, Samrita, all of you are giving the correct answer, isn't it? Now what about the other one? A simple beam of span L carries two equal unlike couples M at the two ends. That's great. The central deflection of the beam EI. EI being constant is given by. You just find out the central deflection. There is some statement mistake here. Is given by. What is the central deflection? How you solve this one? You have a simple beam, that is simply supported beam you have, and two equal unlike couples are acting at the two ends. It means here if you have a clockwise, then here you have a anti-clockwise. So it means both of them will produce same type of deflection, isn't it? Now what will happen? Your beam is going to get deflect like this. As this is a symmetrical picture, one can understand the deflection maximum will be at the center due to the symmetricity. So in other way I can say that the theta, the dy by dx or theta at mid will be 0. Agree or not? The slope at mid of the beam will be 0 because it is a symmetric one and maximum deflection will be occurring here. Which one is the correct answer here? Can you tell me? Now simply if I am applying, suppose moment area theorem, can you draw the bending moment diagram for this one? So bending moment diagram, if you draw, what you will get it here? Simply, what you will get it here? Can you tell me? You will get a rectangle. That's all. Correct? No? You will get a rectangle with M and M. Now if I say that draw the M by EI diagram, if it is beam has a constant EI, that is what he was supposed to write down. EI is constant for the beam. What will be M by EI diagram? The M by EI diagram will be like this. That's all. This will be your M by EI diagram. Correct? Now, once you got the M by EI diagram, how you will get the what he's asking? He's asking deflection. So if he's asking deflection here, you are interested in deflection here. So draw the tangent here, draw another tangent here. You know that how to deal with this moment area theorem, right? Draw the tangent here. Now, and draw the tangent here. And draw a vertical intercept. Draw a vertical intercept at the location where you need the deflection. Now if you will draw the vertical intercept here, and if you are going to take the moment from this position, you are going to get the deflection this portion. Do you need this? No, not at all. You need this deflection. So where you will draw the vertical intercept? Where you will draw the vertical intercept for the moment area theorem? Red, green, blue. Okay, this one. If you draw the vertical intercept here, what exactly you are going to get? See, these are the two tangents. So between the two tangent, the distance between the vertical distance between the two tangent, which one is this one here? If you will get this one, it will serve your purpose. It will serve whatever you want to know. So those who have a confusion regarding from where I need to take, because for the deflection, you know that you need to take the moment of the M by EI diagram. Now moment of the M by EI diagram, if you want to take it here, the moment area, this area is there, but where you will stand to take the moment of the M by EI diagram? No, the area. Either you can stand at 1, 1, or you can stand. That is the kind of confusion generally students will be having. That is why I am just dealing with. If you are taking the vertical intercept here, you will get this delta. Are you interested in this delta? No, not at all. You are actually interested in this delta, the delta at the central one, right? Now take the moment from here, that is M by EI multiplied by L by 2. So M by EI into multiplied by L by 2 and multiplied by L by 4. Multiplied by L by 4. How much you are getting? ML square by 80. That's all. That's all. That will give this nothing but the deflection at C. Whatever maybe at this position, what is C? Maybe deflection at C. That's all. Are you able to understand that? Please let me know if you have any doubt here. Is it clear? As clear as like Sprite? Okay. Find the slope at free end for the beam shown in figure. How will you do this one? What is the slope for the beam shown in figure? What will be the slope here? How you will do this one? How you will do this one? Once again, I will say that you can use whenever you have a cantilever beam. For the cantilever beam, moment area theorem is a very nice one, right? Either you can use moment area theorem or you can use conjugate beam method. I don't mind by using any one of them, right? Use either moment area theorem or maybe conjugate beam method. Both are like, both are okay for me. I just believe that both are fine. Now suppose if you want to use moment area theorem for this type of problem, for this type, see, you can use strain energy, whatever method you want. Now if you want to use the moment area theorem, just I'll just draw the diagram opposite, ulta. Here you just draw the m by I diagram first of all. So moment diagram for this one will be once again constant, right? A hogging moment, so negative moment will be there. But I'll not draw the only bending moment. This is your bending moment. Just a moment. I'll draw the bending moment also. This is your bending moment. Now, divided by I and divided by 2i actually creates the trouble for you. So here you are dividing it by only I, and here you are dividing it by 2i. So what will happen here? Here your m by 2i actually will become lesser. Here you have a m by I. So that is your now m by ei diagram. M by ei diagram. This is your m by ei, and this side you have m by 2ei. Correct? Now you need to calculate the slope at free end. What is the meaning slope at free end? You are just going to compare the slope between theta a and theta b, theta a and theta b. Why? Because for the cantilever portion, if you see here, this is the deflected shape. Now if you draw the tangent, if you will draw the tangent here for the a, the tangent is horizontal itself, so theta a is 0. Now you draw the tangent here at the free end, you'll get the tangent. Now the difference between them, actually this is going to serve the purpose. This is the tangent, the difference between the tangent b and a. This is going to serve the purpose that slope at free end, you will get it here. That's why I'm considering the points at a and b. Now you consider the point at a and b. As per the moment area theorem, what it says that the area inside that will provide you the slope. That's all. What is the area here? Just you calculate, that's all. Area here is m by 2ei, m by 2ei multiplied by L by 2, and plus m by ei multiplied by L by 2. How much you will get? 4, and here you will get 2, so you'll get 4 common, then 1, then plus 2, 3 by 4 ml by ei. That's all. 3 by 4 of ml by ei. You can calculate the deflection at the free end also here, right? If you want to calculate the deflection at the free end, just try at your home. How to do that? Where you will take the, from where you will take the moment. If you have a diagram like this, from where you will take the moment. Remember that for generally for the cantilever portion, you don't have to worry about it. Generally the vertical intercept will be at the free end only. It is the only choices are there for the simply supported and other beams, but for the generally, if you have a cantilever beam, generally you need to stand at the free end. If you take the moment of this whole area about the standing at this position, then you will get, because the vertical, the tangent, two tangents which you have drawn at A and at B, and vertical intercept. Now if you take the moment of this particular area about standing at this position, you will get this height. There is a vertical distance between the two tangents on the vertical intercept, right? Now find the deflection at A. What is the vertical deflection at A here? How you will calculate this one? What is the vertical deflection at A? Can you do this? What is the vertical deflection at A? How you will do this one? Here also, once again, you need to understand that due to the applied load, now consider this length as L only. Consider, I'm sorry for this one. Now you understood that due to the load P into L, there is a moment which will be applied here, and due to that moment, your member CB will be deflected. Your member CB will be deflected like this. Just a moment, I'll create a diagram here. Or maybe if it is okay, so this is your deflected portion of CB. I'm not deflecting too much, so that now due to this rotation of the joint, member BA, now once again you imagine that if member BA doesn't have any load, so what will happen? It will simply rotate, isn't it? The member BA will simply rotate due to the rotation of the joint B. Agree or not? If the joint B is going to get rotated, the member BA also will rotate. Now you have a deflection only due to the rotation at joint B. First deflection, that is delta 1. And that deflection I can write it down. It is nothing but r theta. L is the length here, multiplied by whatever the theta produced at B. Now slope. What is the slope here? That is PL square by 2EI. Isn't it? Correct? Correct or not? Now this is your r theta, right? Then plus another delta will be produced if you have a loading here, that is PL cube by 3I simply, right? This now once again if you have a loading here and this portion is going to get bent, this portion is going to get bent due to the loading, and now it will behave like a cantilever. One can take the another delta which is nothing but PL cube by 3I, PL cube by 3I. That's all. That's all. How much you'll get here? That is PL cube by 2EI and plus PL cube by 3I. Am I correct? Is it PL cube by PL cube by PL square by 2A, right? The slope at due to the slope. No. Just a moment. I'm really sorry. The slope I have written it for not the correct one, right? This slope here is ML by EI. M is P into L. P into L, ML by EI. So PL, that is M into L by ML by EI. That is the slope. I'm sorry for that one. By mistake I have written. Now this is PL cube by EI, and here you have PL cube by 3EI. If you will add these two, how much you'll get? 3 plus 1, 4. 4 by 3 PL cube by EI. Did you get that? 5 by 6? How 5 by 6? What is 5 by 6 you have written here? I didn't get that. Or maybe the comments are not coming. Can you comment here? 4 by 3. Yes, absolutely. Absolutely. Absolutely, Santu and Kavya. Are you able to understand this? How to do that problem? If you have any doubt, please let me know. Is it clear? Right? Now, see another one. A cantilever beam ACB has end A. Now, this is the scenario, right? How will do this one? How will do this one? Now, the scene is only different here. The deflection is asking at the free end. But earlier, actually, I have provided one moment here. Instead of that, here we have a load applied, a concentrated load applied. Now, once again, you have a change in the section. Use the moment area theorem simply, right? Use the moment area theorem here. If he's asking the deflection at this point, or you can utilize the Cantilever also, no problem at all, isn't it? Suppose if you want to use the moment area theorem, how it will look like? Can you do this one? So the bending moment diagram, and from there I'll write down the M by A diagram for this one. Right? For a cantilever, if load is applied here, it is a hogging one, so negative P into the total length. That PL is the total bending moment you have here, that is negative, right? Negative. And it is a linear one. Right? Now if you are dividing it by EI, how much how it will become? How it will look like? Now dividing by EI, what is the bending moment at this location here exactly you have? That is P into L by 2. This height is nothing but P into L by 2. If you are dividing it by I, suppose this is P into L by 2 already. So P into L by 2 dividing by EI, it will become PL by 2 EI, isn't it? And here, but after that one, actually, see at this location, it will go up because the EI get changes. As EI will get change, you will find that you have a at the same location you have PL by 2 divided by 2EI, that is PL by 4EI. This height is PL by 4EI. Which one? Although not necessary to, this is your PL by 4EI, right? Now it was PL will be divided by 2EI, right? Because 2I. Did you get that? Now this is the total moment area, sir, with the load P on the center. How we can do? Okay, I'll just tell you. Don't worry. Now solve it from the moment area theorem. How you do that? What it says that if you want to get the deflection at B, what you will have to do? If you are really willing to get the deflection at B, just calculate the moment. Now you know that already I told you for a cantilever you have to stand at this location, right? Already I have explained there. You see that if you will draw the vertical intercept here, then only you will get the deflection at the free end. Now just calculate the moment of all this moment due to the, so you just divide it in three sections. One is your triangle, this triangle, another one is your this big triangle, right? And then you have a rectangle. That's all. You have a rectangle here. Now take the moment about moment of all. That's all. Take the moment of all. How much you'll get now? So write it down. Rectangle you have, that is PL by 4EI into L by 2. So PL by 4EI into L by 2 is the area multiplied by what is the distance from here to here. The distance, see, little bit of calculative, but no problem. So L by 2 plus L by 4, it will become 3L by 4. Correct, no? 3L by 4. Now plus, what is the moment of this area? That is half into base into height. I'll just use this. Half into base is how much? L by 2 into height is your PL by 2EI multiplied by what is the distance? Distance from here is nothing but L by 2 plus the centroid, sorry, somewhere here the centroid. So L by 2 plus this distance is how much? 2 by third of the L by 2. So I'll write down here, that is L by 2 plus, this is 2 by third, see, L by 2 plus 2 by third of L by 2, 2 by third of L by 2, that is means L by 3. And how much it will become? 6, 2 3 just 6 plus 3 2 just 6, 5 by 6 L, isn't it? 5 by 6 L. Then plus about this one, this bigger triangle, half into base into height, half into what is the base? Base is L by 2 into height is how much? Height is PL by 2EI, not PL by 4EI, PL by 2EI. Okay, PL by 2EI. That is how it will now multiply with the 2 by third of L by 2. 2 by third of L by 2 means 2 by third of L by 2 will become L by 3. Now add all this, that's all. Add all this, you will get, that is the deflection. Add all this. This is PL cube 3 PL cube by PL cube 3 PL cube by right, plus this is PL cube 5 PL cube by 5 PL cube by 48. Just a minute, are you able to see that one, whatever I'm writing now? And then plus how much is you are having here, that half of PL cube by, here you don't have anything, so do not charge not that PL cube by 24 EI. Okay, just add all this, how much you are getting? 48 96 I think you have to take here, 96 तभी ना 3 दूना 6 3 3 9 3 3 3 9 3 9 प्लस 48 दूना 96 5 दूना 10, just a moment, 24 4 4 16 8 4 4 10 4 14 9 9 4 13 23 by, how I'm getting it, I think I did some mistake here, 23 by 96 32 दिया 3 दिया 9 48 दूना 5 दूना 10 24 चौके then 4 10 से 14 9 4 13 I think I did some mistake in the calculation. Please you correct it, right? Please you correct it. Maybe I have written somewhere mistake here that you need to identify. Half into, you just check the calculation, PL by 4EI. Can you check once again the calculation? Just all. We'll check it. Otherwise, if I'll find out, then it's okay. Otherwise, I'll just skip and I'll go for some other question. Now I already have told you how to get that one, right? Just can you check this one? What is the value you are getting it here? PL by 4A is okay. Let's see. This is P, this is L by 2, this is L by 2. You will get P into L, that's okay. P into L by 2 is here divided by EI. Okay, that's also PL by 2 EI. So half into base is L by 2 into height. Height is PL by 2 E. Yeah. Okay, PL by 2 EI out into L by 3. L by 3. 2 by third of L by 2. So 2 by third of L by 2. Some mistake is there, no? Please check that one for calculation. What for the calculation part? PL by first triangle PL by 4 EI. Yes, first triangle. Okay, yes. I got it. First triangle PL by 4 EI. This is total is PL by 2 EI, and I have taken this one. So PL by, but see, I have taken no PL by 4 EI. No, that is for rectangle. So half into base. Okay, here only 4 will come. 2 charge को 16 16 into 6 will be now 96. Here also you will get 96, right? 16 check 96. Now 96 you will take power, but this team here now here then you will get 5, but still here you will get 5, then plus 24 4 you will get 4 5 and 9 18 by 96. Other than everywhere correct, no? 18 by 96. See, that's what I'm getting here. PL cube by EI. 18 by 96 means how much? 3 6 18 3 3 that's all. 6 by 32. I think still there is a mistake. 18 by 96. 18 by 96 PL cube by 3EI. PL cube by EI. I think still you just calculated, some calculation mistakes has been done. Can you calculate this one? Sometimes if you do the mistake for the calculation, it's a bit difficult to identify. What is the horizontal deflection at free end C of the frame shown in the given figure? If you'll find time, I'll check the calculation once again. But meanwhile, can you do this one? The horizontal displacement deflection at the free end C, he's asking. What is the free end C? This is your free end C. This is actually a tricky one. How? Oh, 18 by 96 you are saying, okay. You are saying 9 by 8 4 12. तभी और भी घटेगा ना, 3 3 9 2 3 6 और 16 कितना होगा? 3 3 9 और 16 3 48 3 by 16. You will get 3 by 16. Yes. What is the horizontal? See, this is quite easy and tricky also. If you will apply the moment here, see, whatever the deflection you are getting at C, he is actually not asking the vertical one. Please understand that he's asking what is the horizontal deflection. Horizontal deflection means what? This moment will actually produce what it will do here. This member AB due to this moment will come here, and due to that only, whatever the displacement of horizontal displacement at C will be happening, that is only due to the moment which is acting on the member AB. That BC will get bent, but that bending is not going to get any trouble, right? Bending is like it will produce only vertical displacement. So horizontal displacement is nothing but the displacement. So now one can identify, if you have a moment applied here, what is the deflection here? That is ml square by 2EI. That's all. What is the value of m? That's simply ml square by 2EI. Answer will be A. Are you able to understand that? A 4 meter long hollow alloy tube with inside and outside diameter has 36 mm and 48 mm respectively, elongates by 3 mm under a tensile force of 50 kN. Determine the buckling load for the tube when it is used as a column with both ends spin and with the factor of 3. I think this is from column chapter. It has been coming here. You just solve it. Take it for as a homework. Solve it and give the answer in my Telegram channel. Civil by Ansari Sir. Civil by Ansari Sir, right? I was actually supposed to ask day before yesterday for the column 1 this nice question. Solve it, ask. Then if you have any doubt, please let me know in my channel. Find the horizontal displacement of the roller support here. How you'll do this one? This is also quite simple. How you'll do this one? What is the horizontal displacement at the roller support? See, this one is quite easy if you will use the You can use any method, but here I believe strain energy will become more easy for you. So what strain energy is for anyone? That is m square ds by, so over the member, whatever the strain energy is stored, and then you utilize the Castigliano total strain energy, whatever you will get, differentiate partially with respect to the P, and here actually P is applied here, so del U by del P, if you do, you'll get the delta of B in horizontal direction. So that horizontal displacement can be calculated. Now use that and calculate the strain energy. Now to calculate the strain energy, what you have actually m square dx by 2ei, isn't it? That is you have. Now how you will calculate the m square dx by 2ei? Here you cannot use it because dx is the length purpose, right? And here you have to calculate the total bending moment over the curved beam. How you'll do that one? So calculation of the bending moment over the curved beam, actually you cannot use this one. That instead of that you use m square ds by 2ei. ds is nothing but you can use it as r d theta, right? R d theta. Now what is the bending moment also? Can you write down at section x, if you are considering here, what is the bending moment? So mx will be simply, if you see that bending moment, just I'm seeing towards this side, I have only one force acting here, the force into the perpendicular distance. This is the line of action of the force. Perpendicular distance is how much? If this is theta, it will become r, this perpendicular, right? R sine theta. Now that force into r sine theta is nothing but pr sine theta. That is the bending moment. Use that one. pr sine theta. That is nothing but your bending moment whole square. ds you can write down always r d theta divided by 2ei. Just you integrate it from where to where? You cannot integrate from 0 to pi, otherwise it will become 0, isn't it? You know that from the mathematical perspective. Multiply by 2 and integrate from 0 to pi by 2. Multiply and integrate from 0 to pi by 2. Now you integrate it, and how much you are getting it? That's all. This is your strain energy. Find out the strain energy here. How much you'll be getting it here? The strain energy. So take all other components, 2 will get cancelled. I think I should not carry on. So then r square, p square and r cube, p square r cube, and sine square theta is the only quantity which you have now, d theta, integrating from 0 to pi by 2. That's all. Now if you integrate it, how much you are going to get? If you integrate, you will get pi by 4. Can you just do that? So you will get p square r cube, sorry, ei is also there, p square r cube by ei into pi by 4. Now this is your strain energy. Partially differentiate with respect to p to get the delta, that del u by del p, using the Castigliano's theorem. What you'll get again? 2p r cube pi by 4 ei, and finally you'll get pr cube pi by 2ei. That's all. That is the horizontal displacement of the joint or point B. Horizontal displacement of the roller support. Did you get that? Practice it. This is actually looking like for the deflection, but this is the rigid member, right? A rigid bar of AB is supported by the spring as shown in figure. This is also I'm providing you for the homework purpose. Just do it. This is very easy. Easier than any one of the problem which I have completed till now. And tell me what will be the answer in a description box, or meet me in my Telegram channel for this one. This is very easy. Whatever the problem I have solved till now, this is one of the most easiest one. That's all from my side, and all the best to all of you. Practice it. Join me on my Telegram channel. Ask me whatever you have doubt. Civil by Ansari Sir. There is a bracket, the surgeon, it has written, right? Please ask me there. If you have any doubt, any query, please join me there and ask me. All of you, please take care. Thank you, everyone.